Today we're starting lesson 4-1. The entire unit of 4 is all about systems of equations and inequalities. And when we talk about systems, we're talking about 2 or more equations. For what we're doing in Algebra 1, we're only talking about 2, no more than 2. When you get in Algebra 2, you talk about 3, sometimes 4 equations, and you work with those all at once. But for what we're doing in here, we're just looking at 2 different equations, okay? And what we're doing is we're graphing 2 equations and we're trying to find a solution to those equations. A solution is where 2 lines intersect on a graph, and the solution will be shown as an ordered pair in most cases, okay? And when we get down to the notes further, I'm going to show you what I mean by solution, because just telling you sometimes is hard to understand. I will tell you now, but then I will show you. So when we talk about a solution, it's an ordered pair. So look at these 2 lines right here. They're graphed, and their solution is where they intersect on the graph. So their intersection here is at -1, 1. So their solution would be -1, 1 as an ordered pair. And what that means is if I were to take the x of -1 and the y of 1 and plug them into the 2 equations represented by each of these lines, it would make the equation true. And when I say that an equation is true, that means that when you solve it, the left side matches the right side of the equal sign, okay? And I'll show you what that means, okay? So in looking at some of the definitions here of systems, okay, you have the primary example right here. When you take 2 equations and you graph them on a line and they intersect at one point. So whenever they just intersect at one point, they have one solution, okay? And we call these equations consistent and independent, okay? And we're gonna write what consistent and independent mean, okay? So consistent refers to 2 equations or lines that share at least one solution. Okay, that's what consistent means. They share at least one solution on a graph. Okay, and then over here, I'm going to write what independent means. No, that would be no. So the way that I remember what independent means is they have there's 2 separate equations. So they're not only parallel, but they can be intersecting. And then we're going to talk about, then if you look at this over here, let's look at the next one. Notice you see only one line, but there are actually 2 equations graphed here. And what that means is that both equations were exactly the same. So here I have a line that was graphed from one equation, and then I have the same line graphed again. Basically, all this means is that both equations were identical, and you'll notice that they have infinitely many solutions, an infinite number of solutions, because they both touch all the same points on the line. If you have one line overlapping another line, all of their solutions are going to be the same, because every ordered pair you come across on that line is going to be the same for both equations. Okay, so that means they have infinite many solutions. And this is consistent, meaning the two equations share at least one point on the line, and dependent. And so we're going to write what dependent means over here. And this is just two of the same equation. Okay. Okay, then you have two parallel lines. The parallel lines never intersect, they never touch. So because they do not intersect at any point, they don't have a solution in common at all. Okay, so these are no solution, and this would be considered inconsistent. Okay. One more thing that I want you to write is that infinite number of solutions, anytime you have two lines that overlap each other, they're also called concise. So I want you to write the word concise because you will see this on your homework. Wow, I didn't realize this is so boring. Okay, so let's go ahead and get to an example here. And I'm going to make this a little bit bigger. Okay, so we have two equations here. We're going to graph those equations and we're going to see if they have an intersection or a solution that will be true for both of them. So the first thing that you need to do, if you look up the steps here, is write each equation in slope-intercept form. Okay, so that means that you need to get both equations to y equals mx plus b. So let's look at this first one. We have -3/4 x plus y equals -5. In order to get it into slope-intercept, you have to isolate the y. So what do we have to do to both equations to get this into slope-intercept? Christian? You don't know? Anyone know what we need to do to both sides of the equation? Add 3/4. So we're going to, because it's a negative, we're going to add 3/4 x to both sides. Okay. So that means we've gotten rid of it on this side. And we're left with y on the left. And then 3/4 x has been moved over, minus 5. So now this equation is in slope-intercept form and we can graph it. When you graph the y-intercept and the slope of each equation. The y-intercept is -5. So I'm going to plot a point at -5. And then I'm going to graph my slope by rising 3 and running 4 in the positive direction. So 1, 2, 3, 1, 2, 3, 4. Okay. All right. And then we did number 3, we drew our line. Now we're going to do the same thing for this equation. We are going to write it in slope-intercept form. So what do we have to do? What's the first step to getting this isolated and changing it to slope-intercept? Andy?
Subtracting 4x from both sides.
Yes, so let's subtract 4x from both sides. Get rid of it on the left. Okay, now y still is not isolated. We have to get rid of that too. So what are we going to do to every term in this equation? Divide by 2. And you're left with y equals -2x plus 6. So now I'm going to graph this, and wherever these two lines intersect, that ordered pair will be the solution to both of these equations. So we are going to plot our y-intercept at +6. Some of you had difficulty with this on your last quiz, being able to graph an equation. And so You need to make sure you're able to do that. All right, so then I'm going to graph my slope of -2. So I'm going to go down 2 to the right 1, down 2 to the right 1. And look, it's going to overlap. You can see where it's going to overlap. So then I can draw my line. Okay. And where those two lines intersect, that is the solution to these two equations. They intersect at 4 and -2. So my solution is 4, -2. Okay. So up to this point, are there any questions? Okay, so it does say what is the type of equation? Well, this is where I'm going to use my notes up at the top. How many solutions do these two lines have? One solution where they intersect. That's the only solution it is. It's at 4, -2. So if I come up here, I look at the graph that says one solution, and the name of my equations would be consistent and independent. So down here, I'm going to write consistent and yes.
I must have done what you did as the green line. I must have done the wrapping wrong because I got 4, -1.
So you'll want to make sure that you went, when you graphed this line right here, that you went up 3/4 every time.
Yeah,
What's your y intercept for the second one?
I'm stupid.
No, you're not.
No.
No, in the last class, I had to white out 3 lines because I didn't graph it properly. So we all mess up.
I
on that.
forgot, I made the first one +5, so -5, so I just erased that.
Yeah, I mean.
Okay.
It costs like in the middle. It's very confusing.
So what I'm going to show you is why we call this a solution to the two equations. And I really need you guys to watch what I do. I'm going to rewrite this equation up here. So, and it doesn't matter if I write the original equation or this new slope-intercept equation. So I'm just going to write the slope-intercept. Y equals 3/4 x minus 5. And I'm going to plug the solution of 4, -2 into my equation. Because what I want to do is I want to show you why this is a solution. Because you won't always be graphing your equations. Sometimes you're going to have to figure out a solution a different way. So 4 represents the x, -2 represents the y. So I'm going to plug these into the equation. So -2 goes where my y is. 4 goes where my x is. And now I'm going to solve. And if this is an accurate solution, the left side of the equal sign should match the right side when I'm done solving. So -2 equals 3/4 times 4 is 3 minus 5. And then -2 equals 3 minus 5 is -2. So that equals, that's true. But the thing is just because it's a solution for this first equation does not necessarily mean that it's going to be a solution for the next. And in order for it to be a solution for both, they both have to come out true in the end. So I'm going to do the same thing for this one right here. Y equals -2x plus 6, and I'm going to plug in my ordered pair. So -2 equals -2 times 4 plus 6.
I'm not understanding any of this.
Okay, hold on and I'll explain. So once I plug in my ordered pair into the second equation, I can see that it's true. Since it's true for both, then this is an accurate solution for both of these equations. No, if it comes out not true, that means you did something wrong and you need to go back and fix it and see where you went wrong. Okay.
That's only if you check it.
And yeah, that's only if you check it. And I'm not requiring you to check these. Okay, so we're going to move on to the back. And what I want you to do on the back is I want you to put them both into slope-intercept form. You will see that the first one is already done for you, so you should already be able to graph this. But right now, I want everybody to put this in slope-intercept form. Make sure you can do that part. Okay, so you notice that this one right here is already in slope-intercept form. It's just backwards. The problem with this equation, though, is that your y is negative and you need to make it positive. So how would we change this to a positive?
It's multiple.
Times negative 1.
Yeah, multiply everything by -1, or do what AJ said and divide everything by -1. Either way will work. So I'm going to multiply everything by -1, and I end up with 3x plus 2 equals y. Now, the problem with it written like this is that sometimes it confuses people, okay? But really, once you get your y positive, all you have to do is flip it if it makes it easier for you to read it this way. Y equals 3x plus 2, okay? And so then you just graph that one.
So,
Okay.
you start at 2.
Yep, so on that one, you're gonna start at 2, and on this one, you're gonna start at 2. So I'm gonna graph my first equation first. I start at 2, and then I have a slope of 1, so I rise 1, run 1.
Or there's not one, there's not one.
Is it
Solution is. Oh, the solution.
Okay, and yes, your y-intercept's the same, so that is basically your solution, but I still want you to graph. So the second one, I plot a point at 2, but then this time I'm gonna rise 3, run 1 in the positive direction. And then I can graph my line.
Do you want us to check it again?
No, we're not gonna check this one. I just wanted to show you so you knew how to do it. Okay, so our solution is where they intersect. They intersect at 0, 2. And the type of equation where they intersect at one point, what did we call those?
Consistent, independent.
Consistent and independent. So let's write that here. Okay. Let's go ahead and move down to example 3.
So it's gonna be.
Number 3, you already have the second one in slope intercept. So we just have to turn the other one into slope intercept. So please try this one on your own. Okay, everyone's gonna try this on their own.
Ms. Leatherman,
Yes?
can you go back?
Okay,
Both equations are the same.
That's exactly.
Yep.
Okay, so this is what you got, should have gotten. And what do you notice about the two equations? They're the same. So you just have to graph it once. So let's go ahead and graph this equation. Where are we going to start?
The y-intercept.
Of?
One.
1. So 1. And then how are we going to graph a half? Over 2. Rise 1, run 2. No, please don't do that.
It's a
Are
step.
they gonna be independent?
Not accurate.
Yes.
Wait, they are?
Yes.
They are.
Yes. No.
Oh, quick, right? Quick,
What are your quizzes?
Okay, so since our equations are the same, our lines are exactly the same, that means they share every single point. What is the solution? Go to the front page.
Infinite.
Oh,
Infinite.
Infinite.
Infinite. And I'm going to abbreviate number of solutions. That's how I'm going to abbreviate it. And then what does it say our type of equation is? Consistent and dependent. Yes. So consistent
Yeah, you said independent.
No, he said dependent. It just, when he said and dependent, it's,
Sounds like independent.
Except you pay on.
Why are teachers handwriting so nice? I
mm,
feel like it's just a perk, like being a teacher, you just automatically have.
Nah, Miss Bird.
True, Miss Bird is-
Okay, let's move to page 3. All right. Okay. Both of these lines are already in slope intercept, so I want you to graph them. Graph these lines, and I want you to try to figure out the solution on your own by looking at the front page of your notes. Okay, so when you graph your two equations, you should have gotten two parallel lines. So what is your solution to two parallel lines?
Equal.
No solution.
No solution.
No solution.
Undefined.
Undefined.
Okay, listen. Why, somebody tell me why it's no solution. Emma, what'd you say?
They will never intersect.
Yeah, they don't intersect. And what do we call this type of equation?
Inconsistent.
Inconsistent.
Just like my mental state.
Just like my entire life.
Okay,
Inconsistent.
I've never done
here we go.
that my entire life, except maybe Bible.
All right.
It's consistent.
Then let's go to example 5. All right, scientists studied the weights of 2 alligators over a period of 12 months. Use the tables below to determine the initial weight and the rate of growth for alligator 1 and alligator 2. And then we're going to answer the question, after how many months did the alligators weigh the same amount, by describing the solution, okay? So let's look at alligator 1.
They don't have names?
We need to,
Name them.
you can name
We
them.
need to name
We need to come up with an equation.
Cindy and Rob.
So the answer to the equation is right there in the table. They've already kind of given us the information. So remember, we want this in slope intercept form. So we're going to start out with y equals the slope. What is our slope?
1.5.
1.5. But remember, when we write them in an equation, I don't want them to be written as a decimal. 3 halves. 1.5 equals 3 halves. 3 halves x, and then the y-intercept's there.
Plus 4.
Yep, plus 4, because look, when x is 0, your y-intercept is the y. So plus 4, because this is x, months represent x, weight represents y. Okay, now let's go to alligator 2. Okay, I want everybody to give this a shot first before you copy down what I write. Okay, Christian, what'd you get?
I got y equals 1x plus 6,
Yep,
or just x plus 6.
yep. Okay. Now, what I want you guys to do is I want you to graph these two equations, and we're going to find the point of intersection and then describe what that point about intersection represents. So go ahead and graph, please.
This wasn't-
Okay, so when you are finished graphing, you should have something that looks like this. And we need to figure out where our lines are intersecting. So it looks like they're intersecting at 410. So our solution, 410. Now, are there any questions? Did anyone not get that?
I went
Christian.
negatives.
Yeah, I found that as, wait, oh no, no, they do go up. So I did not go up all the way to the top. I just thought that they were inconsistent. I'll tell you why, because when I did my first line and then my second line, I did not go all the way to the top and get them connected.
Okay, so you have to, so the thing that you have to understand is if their slopes are not the same, then they're not going to be inconsistent. They're not going to form parallel lines. So then that means that you need to keep going further until you figure out where they intersect, or you need to maybe change the numbers on your graph. Okay, we can, if we go all the way to the top, we can see that they are intersecting at 410. Now, the way that we need to describe this is to understand what the X and the Y axis, what your variables are telling us. 4 is on the X axis, it represents months. So at 4 months, something's happening with the weight of 10. So can anybody tell me what this represents? The 4 and the 10.
At 4 months old, they'll both weigh 10 pounds.
Yes. At 4 months old, both alligators will weigh 10 pounds. So at 4 months, both alligators okay. And so that's how you interpret the solution of a system of equations when you're referring to real world situations. Okay. Moving on to the last page. Okay, example 6. Use the information in the tables to write a system of equations. Graph the system to find the point of intersection, and what does the point of intersection represent? So each example gives you a little bit less information in the words, but more information in the tables. Okay, so we are going to look at the 2 radio services. Okay, so you have radio service 1, and we need an equation for it. So what's the first thing that we have to figure out in this table? Yeah.
How much money, like, so,
Well, we need the, well, what I'm asking is we need the equation.
yeah.
Before we find the y-intercept, we have to find slope.
Slope,
The
So
slope.
from a table, how do we find slope?
add, like, see if they
Oh, you
match
have
up.
How many? Okay, so Angelina said how many in between, which is the same as change in y over change in x. So it's going up by 8 and up by 8 and up by 8 on the y. So my change in y is 8, and then my change in x is 1 each time. So I know my slope is 8. So I'm going to plug that into my slope intercept equation. Y equals 8x plus, and we don't know what our y-intercept is. Okay, we have to figure out what our y-intercept is. So what is one way we could figure out what our y-intercept is from this table? Christian?
How many months did you run out of?
No.
Subtract the change in y, change in x.
You could go, okay, -8 would give me a 2, and then -1 would give me a 0, and when x is 0, the y-intercept is 2. But what if this was what if the numbers weren't so pretty and you had to really use the equation to figure this out? What would be another way that we could figure out that the y-intercept is 2? Okay, you would choose one of the ordered pairs and plug it into the equation for x and y. So months represents x, cost represents y. So if y is 10 and x is 1, we take 8 times 1, we can figure out our y-intercept. Subtract 8, and then 2 equals b. So now we have our slope of 8 and our y-intercept of 2. Okay. Now I want you to find the equation for the second table. So everybody work that out, please.
For the second one, right?
For the second
Okay, I got
equation.
Y equals 4x plus 14.
Yep.
Good.
Good.
No. How
Yes.
did you get that? Like,
He said his, and I was like, I don't think that's
Math.
right.
Okay, so now that we have both equations, we can graph. So let's give our graph a title, radio service.
It was so bad.
And then our x-axis represents months. And so I'm going to go by ones and I'm going to skip every other line.
Mhm.
You don't have to, but that's just what I'm doing. Okay, the y-axis represents cost, and on this, I'm gonna go up by twos.
Okay, so you can go.
I went up by fours.
Well, wait a minute. For the first time in your life. Yeah, usually just steals what we do.
Hey, be kind, please, with your words.
Time.
Okay, now we're going to graph. We're gonna graph the first equation, and I'm not going to graph the ordered pairs in my table. I'm just gonna graph the equation. So I'm gonna start at 2, and then I have to rise 8, run 1. Now, because I went up by 2s, every time I go up, I'm going up by 2, not 1. So I'm gonna rise 2, 4, 6, 8, and then run 1. And if you skipped a line, make sure you skip a line when you run 1.
Maybe let's plot your points instead of doing.
You could, but it doesn't go all the way up to 34. Okay. And then 2, 4, 6, 8 over 1. 2, 4, 6, 8 over 1. Okay. And that's as far as I can go. But that's what I'm saying. I'm graphing my equation, not my ordered pairs. Go ahead and do that and then. Okay, now I'm gonna graph my second equation. This time I'm starting at 14 and I'm going up by 4s. So 2, 4 over 1.
We're starting at 14.
And then I'm gonna graph this one. Okay. Regardless of how you graph your points, whether you're graphing the equation or you're graphing your points, your intersection should be the same. So if you're graphing your points, just check and make sure that when you draw your lines, that they're intersecting at the same point. In this case, they should be intersecting at 326.
See, look, it was on the graph.
You did something.
Oh, I see what you were saying. Yes, you are right.
Uh,
All that work for nothing.
Absolutely, I did that first. I did that before I did the slopes.
Like Andy said,
I
he's
was like-
making his point.
I was like,
No.
it's right there. It's just right
But
there.
you still have to know the process.
I had my answer. I didn't even want to get to it. It's
Yeah,
right
we
there.
can make
We
it
can live
work.
out on the streets.
That's why they're
too,
not-
make a living.
Okay, so now we need to describe the solution. So before anyone says anything about the solution, I want you to think in your head, how would we describe the solution of 326 in this real world situation before you say, any- okay, hold on. That is correct.
What happened to?
I know.
Oh my God.
At 3 months, both services will charge the same amount.
No, you have to add 15 body
Well, I
parts.
know, but did you skip it?
Body parts?
15?
No, not body parts, just.
Okay.
objects.
Which is
Are they yours?
body parts.
Yeah, exactly.
Okay, so we're gonna move on to our last example. This time, we're just given a word problem, no tables. We have to come up with the equations from the words. There is a mistake in the word problem, so as I go through and read, I'm gonna have you cross out some words, okay? So, Bo and Celine decide to rent bikes. Shh. There are 2 shops from which to choose. Rent a bike charges $10 per hour. I want you to cross off the words per bike, okay? Bike-O-Rama charges $15 per hour, cross off per bike, but with a deposit of $15, and again, cross off per bike, okay? Those shouldn't be in there.
Yeah, I know.
Okay, at what number of hours will both shops charge the same amount? And what is that amount? Okay, so let's look at rent a bike. They charge $10 per hour. What would your equation be for that? Y equals 10x. And then what about equation 2? $5 per hour plus a deposit of 15.
Okay.
Oh, someone's taking a dump.
Once we have both equations, we need to graph. So we're going to title bike rentals. Okay, and then on the x-axis, I'm gonna go by ones and did I skip lines on my last one? Let me see.
Yeah, you probably.
Oh, I thought you were talking about the line.
I can skip lines on my x-axis, so I'm gonna skip lines. So 1, 2, 3, 4, 5, 6, 7. And then we have to title our x-axis. What does the x represent?
Hours.
Yes, number of hours. They didn't leave us a whole lot of space down there.
It's okay now.
Okay, the y-axis, we're gonna go up by 5s. We're not gonna skip.
What would be on our side?
What is the y? Yep, total cost. Okay, all right. So now we are going to graph the first equation. So the first equation, where am I going to start?
You could skip.
You could skip lines, yes, if you wanted to. I went up by 5s, yes. So where am I going to start with this first equation when we're going to start at 0 and we're going to go up by 10. So 5, 10, and then over 1.
Oh.
Okay.
Wow, rent a bike is just a ripoff,
You think so?
definitely. Unless you can, like, what are you gonna do with a bike for 1 hour?
All right. And then Bike-O-Rama, that equation, we start at 15. Oh, sorry. And then we go up by 5s. 5, 1. Oh, there's our intersection. Okay. And then we can draw.
Let's just say something that.
What are you going to say? I'm not determined.
All right. So what is our point of intersection?
3:30.
Yep. 3:30. And what does this solution mean? Anyone else who has not spoken up yet?
Would it be?
I answered.
Well, yes, okay.
Go ahead, Christian.
Well, I don't know. What would it
Okay. This is why I kind of said it that way, because when I call on you,
Would it be?
You never know.
Wait, would it be consistent?
No. So what I'm asking is for you to describe the solution.
They get 3 hours.
At 3 hours.
Yes.
Bike,
Yeah, boy, it's a lot.
At 3 hours, they cost the same. Yes. So at 3 hours, both rental companies
Have enough time to work on homework.
charge $30.
This was an easy lesson.
Really.
All right, there. If it's so easy.
All right. And that concludes lesson 4-1 with some minor blunders.
Yeah.